Everyone. So this is the second part of the video lesson from lesson 7-6. And I'm going to just tackle this little section right here and then example 2. And I think that's everything we have to do. Okay, so this is really more of a reminder of things that we've talked about before. Okay, because we have talked about this, especially in terms of our calculator and why this makes a difference. It's getting to be more and more important as we go through that you recognize the difference between this and this, okay? And I'm going to do it. Let me do one without a fraction exponent first, just to make sure you really understand here. When you put a negative number to a power, but you don't put parentheses around it, technically the way we treat this, even if this isn't how your head is doing it, technically the way this is supposed to be treated is like a 3 to the second power that is being made negative, okay? And that's how your calculator is going to handle it too. So if you try to do negative 3 squared and you put it this way, really what you're doing is 3 squared is 9 and then you're making it negative, okay? So this thing is going to come out to equal negative 9, okay? And this is one of the most common errors I see even in a calculator. I'll say, okay, what's negative 3 squared? And people will put this in, all right? And then they tell me negative 9. If you're actually trying to square the negative 3, you need to be writing it this way, negative 3 squared. Because this is saying, oops, I didn't mean a parenthesis there. This is saying negative 3 times negative 3, which gives me positive 9. Okay, this is the correct answer to negative 3 squared. This is really like negative 3 squared. Okay, that's hard to verbalize, but there's a difference. There's a big difference here, and there's an even bigger difference here. Okay, because this one here, if I'm doing 9 to the 1/2 power, I'm asking myself, what to the power of 2 makes 9? And I probably should have actually mentioned this in the first video, but a power of 1/2 is really the same as taking a square root, right? A power of 1/2, that's the connection with roots here, is 9 to the 1/2 power is going to be 3, okay? And then this is just saying make it negative. So my answer to this would be negative 3, okay? But this one is asking me what to the power of 2 makes negative 9. All right, that's the big difference here. One is asking me for positive 9, one is asking me for negative 9. Negative 9 is impossible unless we're using imaginary numbers. And for the sake of this content, we really don't use imaginary numbers here. So if you try to do negative 9 to the 1/2 power in your calculator this way with the parentheses, you're going to get no solution, okay? Because this thing is not possible. All right, so just again, to reiterate my point here, if you've got the negative outside of the number without parentheses, that's really the big thing. If there's no parentheses there, you just apply the power to the number and then make your answer negative at the end, okay? But if it's written in parentheses like this, a lot of the time it's going to come out to be no solution. And we're going to talk more about that as this chapter goes on. But that's because we can't take a negative and split it into an even number of parts. Okay, so let's jump down to something a little bit unrelated. Let's look at this example 2. And we're looking at doing some solving here. And remember, solving means figure out what x equals. That's our goal here. So we have x to the 3rd power equals 343. And actually, before I start that one, let me give you a different one. Let me give you x squared equals, I don't know, 100. We've done lots and lots of these problems, right? You would probably tell me to take a square root on both sides. If you think about what we just talked about, a square root is really the same thing as a power of 1/2. So I can also think about this as doing a power of 1/2. If I think about my power rule here, when I raise a power to a power, I multiply. When I multiply these two together, that's just going to make a 1. 2 times 1/2 is just 1. So that gives me x equals, and then 100 to the 1/2 power is 10. Okay? So applying that same logic down here, if I have x to the third power equals 343, I can solve that by raising to the power of the reciprocal. I could raise to a 1/3 power. Okay. I'd be interested to know how many of you know this off the top of your head. I may ask you tomorrow just to see. 343 to the 1/3 power. What to the third power is 343? This is one that I'm hoping you memorize eventually. Correct answer here is 7. Okay, so x equals 7 for that one. So then, how do we get rid of a power of 1/4? That's kind of backwards from this, right? Well, to get rid of a power of 1/4, we're going to raise to a power of 4. Okay, because 4 and 1/4 are going to cancel. All right, and then I just have to do 5 to the 4th power. That you can use a calculator on that if you needed to, but 5 to the 4th power is 625. All right, last one. Always save the most complicated for last. With this one, just like every other solving we've ever done, we need to get rid of these other numbers first. So I would start by adding 7 to both sides. So now I have 3x to the 1/6 power equals 6. And now I'm going to get rid of the 3. So divide by 3 on both sides. I'm going to go up here. That's going to give me x to the 1/6 equals 2. And now this is the part that's new. To get rid of a power of 1/6, I will raise to a power of 6. Okay, so those cancel. 2 to the 6th power is 64. So x equals 64 here. Okay, that should do it for lesson 7-6. That was a nice short chunk of examples there, but you should be able to do the rest of the problems on your assignment for tonight based off of that example. Okay, so I believe it's Lesson Master 7-6 for tonight, and we will make sure to talk about this tomorrow, and then tomorrow we're going to start from here and add one more step to these types of problems. So you have that to look forward to.